let's get started. But basically, there are resources that I've posted in the resources link, and also I've pinned some document link and also a Slack channel link to the chat box. So you should be able to access some of those. Thanks for joining in. I have some folks from Onehouse join the workshop as well to moderate and help me run this workshop. So with that said, a little bit about me. I'm Sagar. I'm a solutions engineer here at Onehouse. Been with the company for about 3 years now. And over the course of 3 years, I've been part of several product launches, feature launches. And I'm excited to be with you guys to showcase our new launch, that is Kubernetes Quanton Operator. Now, today's agenda is pretty thin. Just one slide that talks about that has barely any text. So no more yapping from me outside of that one slide. Then after that, we can, move on to the workshop content itself, which will probably take majority of the session. This is the second session for today. So, during the first session, we were able to run one example out of the 3, but the workshop itself is designed to be self-paced. So if you do get stuck on something that isn't able to be cleared within the session, you can always hit me up on Slack or message me on LinkedIn, or even Google your way through whatever issues that you're facing. The doc link itself that I've posted on the chat box should, help you guide through the workshop step by step. That's pretty much what I'm going to do myself now. So once the workshop is concluded, I'll show you the getting started example in the workshop. I'll also show you some pretty cool Agentic features that we have launched over the past few weeks to few months. I'll also send you home with a benchmark exercise that you can, run to compare open source Spark versus Quanton Spark. All of this is done locally. So all you have to do is have a laptop with Docker installed. Everything else is, can be done in this session. So with that said, I'll walk you through what is Quanton Kubernetes Operator and how it is different from the Quanton engine in Onehouse. And from there, we can jump into the workshop itself. So the Quanton Kubernetes Operator we launched a month back is a drop-in replacement for your open source Spark operator. So if you're using Kubernetes and if you're on Spark, you're most likely using Spark operator, right, with kubectl. So you can add Quanton engine on top of it and expect massive acceleration. So a little bit of backstory. We have been rolling out Quanton, or our customers have been using Quanton within Onehouse for the past year or so. So we separated Quanton from the platform, took all the best features and put it inside of this Quanton operator, and which you can download for free today and play around with it within your laptop. Basically, it deploys Quanton accelerated Spark pods in your Kubernetes cluster, wherever you are running your Kubernetes. It can be on any cloud, AWS, GCP, Azure, or even on-prem or any air-gapped environment. So you basically run that single Helm install command on your Kubernetes platform, and that's pretty much it. Within a few minutes, you can get started and going. The way it is different is that from Onehouse's Quanton engine is that Onehouse's Quanton engine needs to be deployed with a data plane. It's more of a managed data platform, whereas the Quanton Kubernetes Operator is a standalone operator that you can deploy in your Kubernetes cluster. So that's the biggest difference. Again, it's an extension of your Kubernetes Spark operator, and you pretty much only pay the infrastructure cost, and hopefully Quanton can like massively accelerate your Spark workloads. So you get to pay a lot lesser than what you're paying. And that's pretty much it. So we have 20 more minutes to actually power through this workshop. So you can either scan this QR code or hit the link that I pasted in the chat box, which will take you to our workshop, self-paced workshop page, which can get you started right now. So hopefully you're with me. So let me switch my screen. And I'll also talk you through what is present inside this workshop. So even if you're not able to complete the workshop in this session, you still have the context to finish it up as we are going, right? So this workshop has 3 examples. Basically you have to start setting up the project, but let's get there when we get there. So let's say you set up the project. The first example that you have to work through is this getting started, where we calculate the value of pi. Popping up the barcode again. But let me paste in this link once again. This barcode will take you to this docs page anyways. So I'll quickly shift my screen. So the first example here, it is in step 2 that runs and calculates what is the value of pi, modern day hello world example, right? And the second example, I will walk you through the cool Agentic features that we have launched. So once you finish the pi example, you can also follow through this. But there are a good amount of the steps for you to follow through. So this spins up a larger job, kind of a problematic job, which will purposefully exhaust your garbage collection, and it basically showcases how the agent can be of real help when you're running large-scale jobs, right? So the third example is to actually run the benchmark itself. So let's say you get through these 2 examples, you can run the benchmark and side by side see what open source Spark operator does for this TPCDS 1 GB benchmark and what Quanton Spark does. If prior experience counts, I've seen for this 1 GB data set, somewhere between 1.5 to 3x improvement. So that's something that you can expect. But as you scale up and as you run this in your production environment, like let's say with a 10 TB TPCDS data set, your results will be wildly different in a positive sense. So with that said, I'll let you sign up to Onehouse, create a project. That's step 1. I'd love to get you started there. So once you click on this email, this link, you would see something like, let me open my private window. cloud.onehouse.ai/sign up. It gets me here. I'll not sign up now, but sign up is pretty easy. You can use your work email or even your personal email, to get started. So let me use my previous email that I used to sign up with. So what you see here is a flow that asks you to prompt your Gmail and your password. Let me give mine. So I'm all in. Hopefully you're able to follow me in this step. So basically once you sign up, you'll see a screen like where it'll prompt you to create your project with a project name. I gave mine as first project. You can do something similar. But basically, you'll be brought into this page where you can see the jobs that you've run and also download a pretty important step that is required for you to actually follow through the example, right? So because I've already used this project to run some examples, I see some jobs here, but in your case, it's going to be very fresh, right? So what you can do is download this YAML file, and this YAML file has all the values that you actually need to spin up your Spark job. This has some secure credentials, so don't commit it anywhere. So you can inspect the YAML once you download it. I've already downloaded it, so I'm not going to hit download right now. But this is a pretty thin YAML file. Let me put a poll and see how many people are in yet. I see 4 people, marked as yes. I'll give a couple minutes for everybody to join in. As you are signing up, let me also open my terminal. All right, 5 is a good number. Let me start here. So the first step here is for me to install Minikube, kubectl, and Helm. Because I have all 3, I'm going to skip that single step right here, and I'll shift to doing Minikube start. But if you don't have Minikube or kubectl or Helm, you can basically brew install it if you're on macOS, or you can follow the docs to install it if you are on Windows. But basically, you need to have Docker installed and started for this to begin with. So make sure that you have your Docker up and running. Like I said, this workshop is fully self-paced, and I've measured myself. I was able to run the whole workshop in under 25 minutes. So, feel free to take this through, even if you're not able to, wrap it up within the session. So now that Minikube is started, Spark operator is already added. Helm update. Installing the Spark operator. In my case, I cannot reuse the Spark operator because I already have one. But in your case, this will succeed. In my case, it's a no op. And let me see if there is something running already. I do see. These are the operators that that I started for the morning session, so they're still running. So now I would install the Quanton operator, basically do a Helm install and path to the Onehouse values.yaml file that I downloaded from the previous step from Onehouse UI. So quick look into this command. All I'm doing is downloading and installing the Quanton operator. So the secrets are there in this onehouse values dot workshop dot YAML file. So you should not have any problem installing it. And also I've enabled the agent here, which means, as my job is running, I'll be able to like open the Spark UI and I'll be able to use the Spark AI agent. But if you don't want to use it, you can always remove the flag and you should be able to work without the agent. So let me run this. Okay, so now that I already have it, that's why it's failing here. Let me start, let me see what operators or what pods are present. Okay, this is the expected thing to see. I already have the controller pod. In your case, the Helm upgrade would have succeeded and you would have the controller pod up and running. This will probably take a minute or so in your end, but since I already have the controller running, I don't have a problem right now. Now, once that is done, what I will do is I'll submit the Pi example. For this, I would have to clone the Quanton Operator GitHub repo. But in my case, I've already downloaded it and I'm inside the repo itself. So, I don't have to clone it again. I can basically do kubectl apply. This is where I submit the Spark job. Up until now, we have been setting up the environment. This is where I actually submit the Spark job and I'm going to see it running. So this has been unchanged, meaning, in your case, you would have successfully applied it and it would have started running. So in my case, I already see some jobs running here. Now let me wait for, or basically restart the job and submit it once again. Okay, let me give it a minute to pop up. Okay, now that it's running, I'll be able to, there you go. see if my pods are up yet. It is running. Let me see if the application ran already. Okay, there you go. So you should be at this spot. Pi is roughly 3.14. That's good to know. Let me see where people are at this point. So given the steps in the workshop document is pretty self-paced, what I'll do is I'll switch to presenting the agentic features now. And as you are looking at my screen, or if you want to work through this like after the workshop, feel free to. So let me switch my screen here and bring out my docs. So now that the application is, run successfully, let me switch to the agentic example. I'm going to start running this script right here, which will basically start a bigger job, bigger than calculate Pi job, so that it gives me an opportunity to show you the Spark UI and show you the Spark AI agent feature itself. Now that it's already up, let me open port forwarding right here. Okay, port forwarding is also up. I'm going to open the Spark UI. Usually this job involves two phases. One is, you basically generate the data, which is required for TPCDS benchmark to run. And the second phase of that is you run the actual benchmark. And this benchmark is kind of heavy. So, it's 10 gigabyte worth of benchmark, but it generates 3 gigabyte worth of data. So it might take 5 minutes, but the overall exercise is, it can be done within 10 minutes or so. But the data generator from my side is already, it already ran in the morning. So, the application wouldn't generate data again. It directly went to running the actual application. Now, this is a pretty typical Spark UI. So, if you had followed the example that's there in the self-paced workshop, you would have a similar screen like what I have here. Here, you'll be able to look at the agent itself. The first step for you to follow through this example, or even have a conversation with the agent, you would have to configure your API key. For the purpose of this workshop, I've created an Anthropic API key, which will be alive for an hour or so. So if you are in need of an API key, you feel free to use the one that I'm going to share in the chat. Just a moment. So you can use this API key. I'll keep it alive for an hour. So feel free to experiment with this API key and the Spark AI agent feature. But outside of this, if you have a Gemini model or if you have ChatGPT API key, you'll be able to use them as well. So once you have configured the API key, which I've already done, you can go to the AI agent and start asking questions. There are some boilerplate questions here. You can either ask, you can either use this, or you can basically ask the agent to tell you how many jobs have completed or how many stages have completed, like so. So this AI agent is contained, or it basically has the context of the entire Spark application, meaning it's not just page-based, right? Like if you open this Spark application or Spark UI in a Chrome window, you'll have Gemini answering some questions, but it is unfortunately like, blocked on that specific page, which has some metrics or some data, right? But the Spark AI agent that you are seeing right here, it has the context of the entire application, so it can like go through the entire application and find out what's happening, right? A good example of that would be looking at this monitoring tab. It can show you what is the GC pressure, what is the task duration on average, or P95 or max, or how your data is queued, or what is the disk spill right now, how your shuffle is doing, how many executors have been up, did it scale up, did it scale down, all of that good stuff, right? So again, like if I were to hammer home the point, it has the context of the entire application. One other cool feature that I like is that it shows you any problematic areas that you can improve in your Spark application, right? Some of the common problems that I've seen or that we have seen, running Spark in production for, I don't know how many years. It's either GC or there is some data skew, right? So GC pretty much is something of an infra problem. Figuring that out, first of all, is a big pain, and solving it is a different beast altogether, right? And data skew is, it's probably a bad data modeling, but finding that out is also a pain on its own. But what we have tried to make it easier is that it surfaces the problems, like so that you can easily diagnose what's whatever is surfaced by the agent itself. You can basically have a conversation with the agent as soon as you see problems like this. Just by quickly scrolling through all the alerts, most of them are GC related. And let me go through this a little bit more. There are a lot of stages that were impacted by GC here. And there is some fetch weight high kind of warning. This probably is not that big of a deal. There is a record skew, which is another common culprit in Spark applications. But let's choose one of the critical issues and have a conversation with the agent itself. So in a few seconds, it'll be able to tell you which stage is bottlenecked. Looks like stage 4 or 5 is the worst offender here. Let's see what does the agent say about the analysis. Here, if you see stage 4 or 5, you can click and go to the stage itself. The executor runtime is 47 milliseconds, but then the GC time itself is 33 milliseconds, which is more than half, right? 70% in fact. So the root cause here for this GC, right now, this is a very minuscule stage, right? But in production, you can imagine if you're running large ETL jobs, you're gonna shuffle like probably, tens of gigabytes or hundreds of gigabytes, even terabytes of data, right? At that point, this GC problem will be more pronounced. So that will become a bigger headache there. So it says small heap, no G1 GC, and large serialized result. Let's see what recommendations that it comes up with, right? It asks us to increase the executor memory. It asks us to add G1 GC flags, which is pretty nice. And it also asks us to adjust the heap balance. So all of these things need Spark application resubmit. Which I'm not going to do now, but you can do it like with the Quanton application.yaml file that you saw me submitting when I did Helm install. So it also shows you what the priority is, and you can always see what the low hanging fruit is. In this case, just improving the executor memory will get you to a long, will give you a better result right off the bat. So let me see how many applications complete so far. Oh, this is an application. So how many stages have been completed so far? Okay, nice. So pretty much, I think, like, we are almost done here. Based on my experience, this took anywhere between 7 to 8 minutes. So let me see if it is almost done. It's still going on. Let's see. So that's pretty much what I wanted to cover. The goal of this example is to show you the cool agentic features. But outside of this, there was one more example that I was hoping to cover, which is running the actual benchmark itself, right? So let me quickly shift my desktop tab and show you what that is going to look like. The next one is running and seeing the Quanton performance acceleration like live, right? Let me see if I can run this live, but I've also run this right before this experiment. So I can quickly scroll through and show you what my results look like. So it should be right here. Okay, it's done. Once my image has loaded successfully, I'll be able to load the Spark or open source Spark image as well, and then I can quickly run the benchmark. Okay, this is done. Okay, this is also done. Let me start the benchmark suite. As it is running, now it is generating data. The next phase would be running the benchmark on OSS Spark, and the phase after that would be running the benchmark on Quanton-enabled Spark, right? So that will give you a good side-by-side comparison as to what OSS Spark performance looks like versus Quanton Spark, right? So like I said, just before this session, I did run the experiment myself. First phase was generating the data. Second was running OSS Spark TPCDS. Third phase was running Quanton Spark, right? And then it collects the data and outputs in a way that you can easily see and understand. So there are a set of 99 queries that ran. Total time that took in OSS Spark is 157 seconds, whereas Quanton Spark took 120 seconds. The speed up is 1.3x. Bear in mind, this is, a Docker example that is running locally. So if you run a bigger workload on a cluster, you'll see, way bigger speed up, right? At least from my perspective, I've seen like 3x, for example. Now, with that said, let me see if people have any questions here, or otherwise, once you're able to run these jobs, you'll be able to go back to the Onehouse console, which I shared before, Let me share again, and you'll be able to see all the jobs that you've triggered in this session. Let me refresh here and see if there is any successful execution that we ran through. There you go. So 328, there was a TPCDS that was run. This was the session. This was the benchmark that I ran before the session. The PyJava example that we ran during the session is also complete. And then the Quanton TPCDS agent example, where I showcased you Agentic AI feature, is also complete. So you'll have a similar UI, you'll have a similar experience to see like what happened when, when you're following through this example. Now that my TPCDS example is running, once that is successful, I'll also be able to see that job successfully run here. With that said, I'll switch my screen back to my presentation. Now that we have somewhat wrapped up the workshop session, you can always join us in Slack. So if you were not able to run this workshop session with me hands-on right now because of any problem that you may have, if you had hit any hiccups, feel free to ping me or ping any of us in the help channel in the Slack. It's completely free to join. It's a community having people from Onehouse and also people from different companies trying to help each other. So you can join us there and you can ask any question. And I hope I'll see some of you there. If you want to connect with me on LinkedIn, feel free to. You can find me, as Sagar Lakshmipathy in LinkedIn. But I'll also keep this session open for 5 or 10 more minutes to see if people have any follow-up questions that I can help answer. Like I said, I'll keep the API key up for another hour and tear it down like later. So if you wanna use that key to experiment with the Spark K8s, and feel free to. I see, one response about not being able to sign up successfully. Unfortunately, I'm not sure how to figure out who, was not able to sign up successfully. So if you want to post a message in the chat screen, I'll be able to help you out. Or if you want to ping me on Slack, feel free to do so as well. I think we are well over time. So thanks for joining again. It was nice seeing everyone here. Feel free to play around with the operator and with the agent, and feel free to let us know if you have any questions. We'll be able to help you out. Thanks everyone. We'll see you soon.